Hello everyone! Did you hear about first order reaction before? Or do you want to learn more about it? So you are in the right video. The study of the base of chemical reactions is known as reaction kinetics. Some reactions, such as the detonation of pyrotechnics, can happen quickly, while others, such as rusting, can take years to occur. First of all, let's talk about the definition of a first-order reaction. A first-order reaction is a reaction that depends on the concentration of only one reactant. Other reactants can be present, but each will be zero order. And here you can see the rate law of the first-order reaction, where K is the first-order rate constant, which has unit of s to the power minus 1. The following graphs represents concentration of reactant versus time for a first-order reaction. Plotting the natural logarithm of reactant concentration with respect to time for a first-order reaction gives a straight line with the slope of the line equal to minus k. If a plot of reactant concentration versus time is not linear, and the plot of the natural logarithm of reactant concentration versus time is linear, then the reaction is first order. And when a reaction overall is a first-order reaction, then the rate of reaction is simply proportional to the amount of that reactant. One of the excellent examples of a first-order reaction is nuclear decay. The rate of decay is simply proportional to the amount of the radioactive isotope. This is due to the fact that any isotope has the same chance of decaying at any given time. So, the more isotopes there are, the more they can decay, and over the time, fewer isotopes will be able to decay. In radioactive decay, the number of radioactive atoms decaying per unit time is proportional to the total number of radioactive atoms present at that time. And as you can see here in the equations, since the decay rate is proportional to the first power of radioactive atoms present, therefore radioactive decay is the first-order kinetics. Now, let's talk about how to determine reaction order experimentally. The balanced chemical equation here has one reactant, so the rate law for this reaction has this general formula as you can see here. Now, to find the value of M, which is the order of the reaction, we can measure an initial concentration of dinitrogen pentoxide and record the rate as it decomposes and measures the new rates. In conclusion, we talked about the first-order reaction and its definition. We also described the rate law, and we took a look at the nuclear decay as an example of the first-order reaction. And finally, we explained how to determine the first-order reaction experimentally with an example. Hope this was helpful for you, and thank you for listening.